So, good morning from southern Bavaria. My name is Burkhard Stubert. I am a solo consultant building Qt embedded systems. And you see here a couple of the systems I've built in the past. So, operator terminal for a sugar beet harvester or for a forage harvester. A couple of infotainment systems. I've done some metal origami, or better, it's metal sheet benders. And today's topic is I will tell you how to set up QtCreator in 5 minutes to do cross-compilations with CMake for any embedded platform. So when you start building a Qt embedded system, the first thing is you have to build a Yocto Linux image. Then you have to build an SDK. Then you have to set up QtCreator so that you can just hit Control R for run, and then it builds, cross-builds your application. It deploys it to the embedded board, and it runs the application on the embedded board. And that takes a lot of time. What you want to do actually is you just want to develop your Qt application. You do not want to build Linux systems and configure QtCreator, who doesn't like to work with CMake. So that is actually not your core goal to do these things. It's certainly fun, but it's not your core goal. So the Qt company has done quite a good job for the commercial Qt version, for the Ubuntu Qt version, in getting in automating all these things. You can download a pre-built Qt SDK. QtCreator is set up nicely somewhere behind the installation scripts, and then you can start developing your application in 30 minutes. This wasn't available so far for Qt under LGPL, and that's what I actually did. So it took me too much time, so I thought about how can I automate it, and today I show you how you can automate the QtCreator setup. So now you're on for the 5-minute challenge. Will be a bit longer than 5 minutes because I explain a couple of things, but running the script and setting some things in QtCreator, that's a lot less than 5 minutes. So let's go for that.
Let me briefly describe my setup and the prerequisites to run the QtCreator configuration script. You're looking at my working directory for this talk. It contains a bin subdirectory with the configure script, which we will run, which will do all the magic. It contains the source code for a very simple internet radio application, which plays exactly one station. And the goal is to cross-build this application from QtCreator, deploy it to the Toradex Wordin IMX8M mini board, which you see on the right-hand side here, and then run it on the board. So what we want is exactly the same what we do on the PC. We just hit Control R for run, and then QtCreator builds things, installs things, and runs the application. And we want that for our embedded device in the very same way. The final thing in my project directory is the setup env-talk script, which I will quickly source. And it sets a couple of environment variables which are pretty useful during this talk and make all the commands a little bit shorter. So I have built an SDK for the Toradex Wordin board. It's actually with Yocto Wordin Dunfill. and the env setup file variable points to the environment setup script for the SDK. So to use an Yocto SDK, you must source this environment setup script. The next variable points to the base directory of my QtCreator installation, which is the one which comes with Qt 5.15. So it's a fairly recent QtCreator version. The script needs that to know where to write the configuration scripts, and it uses the SDK tool utility from there to actually manipulate the configuration scripts. So what will the configure QtCreator shell script do? It will create a kit with all its parts like compilers and debuggers and CMake binaries and so on, called Goldfinger. It needs the environment setup file from the SDK, and it needs the location of the QtCreator, and it needs the name of the device. In QtCreator, these things will show up in Tools Options kits. So obviously there's nothing there yet, so you won't find any kit or compiler or so-called Goldfinger, and you shouldn't. We want to create them. So, and the script creates things like, say, the Spectre kit with all the usual refinements here. And it does that automatically. Same for the Qt version, compilers, debuggers, CMake, and so on. It also creates a device called Goldfinger, so that QtCreator can automatically deploy the binaries and other files to the board. Now we close QtCreator, because we will generate configuration files for QtCreator, and if QtCreator is running, it won't pick the newly generated files up. There's one thing we have to make sure. We have to make sure that we can SSH into the board without providing a password. So now we are in the board as root user, and we see from uname that, yeah, it's not my PC anymore, but it's an IMX8 board with the ARM architecture with 64 bits. And it doesn't have any SSH authorized keys. And that's what QtCreator will deploy. So QtCreator will deploy the public key on the device and then use that to authenticate when logging into the device. Let's go out of the board. Now let's do the magic and run the configure script. So I copy this into the command line, hit return, and that was all the magic. So you see that it removes the kit and its parts. So that only makes sense if there was a kit called Goldfinger before, which at the moment there isn't. But if you have to run the script a couple of times to get things right or so, then it can remove things. And you can actually specify the -- remove option to remove a kit. Then it generates the CMake toolchain files here. And it finally generates all the parts for the Goldfinger kit. So let's check in QtCreator whether these things really have been generated. QtCreator, there it is. Let's run that. I see a couple of messages there, which I will remove. So let's check that in Tools, Options, Devices. Okay, that was the last one we looked at. You see a device Goldfinger. That's fine. Let's look at kits. Yeah, there is a Goldfinger kit here with all the usual refinements, compilers, Qt version, CMake tool, a CMake generators, and a CMake configuration. If there is a need for you to change, say, the CMake configuration, you best clone your kit, and here with this button, and then you can change the definition. You cannot change auto-detected kits, so unfortunately not. So under Qt versions you have a Goldfinger version, and it's in the SDK somewhere down, deep down in the SDK. You have a compiler for Goldfinger, a C and a C++ compiler, a debugger, and CMake. So the first thing we have to do, we have to make sure that the public key is on the device, which we saw it isn't yet. So you see here I have a private key file already because I have been working with this board and other boards before. So I have a QtCreator generated private and public key already available. If you don't, you just click Create New, and you can generate and save your key pair, which will be called QTC_ID. So what we do here, okay, we have to check the host key, and we have to deploy the public key we have on the board. We select it, it's the QTC_ID pub. Let's do that. Oh, yeah, that was quick. It's deployed, so now it's on the board, and QtCreator can now authenticate with the public and private key. Let's check whether that is really working. Let's do a test. And yeah, there's some red in here, but don't worry. It just tells you that rsync isn't installed on the device, and that it will use SFTP for uploading binaries and other files to the device. So everything else is fine. So it detects the Linux kernel of the device with an ARM architecture actually, and SFTP is working, everything is fine. You can actually see the running processes on the device, so all is working fine. Or you could even open a remote shell on the device. So let me pull that in, there we go, and uname -a. We are on the device, and we now have an authorized key files on the device. Close terminal, apply. So now that we have the device set up and have the communication between the PC and the device set up properly, we can move on to building, cross-building the device, deploying it, and running it. So let's look at that. Just moving Qreator a little bit over there, so we see it in full beauty. Let's go to projects here. And we are still in the kit for the PC. Let's go to Goldfinger and to build. So that's always the critical moment. If you don't get an error here when the first CMake run is done, then you're good. Then you're through the worst already. You see up here, you see the CMake variables from the Toolchain file, all there. And here you see some other CMake variables. Build step, okay, it builds by default, it always builds all. That's not really necessary. It's good enough to build just QtRadio, which is our main application. We can add some arguments here. Say, hang on, that's the wrong line. So we do that here. So say we want to have 16 cores working in parallel on the build, which isn't really necessary here because it's it's just one source file which gets compiled. So let's see whether the build is working. Yeah, you see that is from CMake, so it detects the compilers correctly, which can be a bit of a trouble when you create the toolchain files manually, but that worked. And the compile output looks pretty nice and tidied up as well. So next step, go to let's configure the run settings and the deployment settings. So the deployment settings are here. We deploy to remote Linux host. Okay, let's see. Here, install into temporary host directory. We clean that directory first before installing, and the rest is okay. Check for free space. Let's give it 50 megabyte. It's not really necessary for our example, but better more than less. Then we kill, that's the command to kill the current application instance. So before QtCreator deploys an application, it kills the currently running application. We leave that as the default. And we upload files via SFTP incrementally. That's all good and fine. So here, run QtRadio on device Goldfinger. That looks promising. We tell QtCreator the name of the executable and where it is. Use a local bin QtRadio. Hit return so that QtCreator really takes over our entry. If you just tap out of it or click with the mouse somewhere else, you get a partial executable name, and then the execution will fail. So I fall for that a couple of times. Let's give a working directory, that is hit enter, use a local bin. And we have to set two environment variables. So the Verdin board uses Wayland, so we have to set the QPA platform to Wayland EGL. And we have to set the XDG runtime directory, to /run user 0. So that should be all now. It's all looking pretty good. And let's take it for a spin. Control R. Off you go. And you hear the music. Bit loud, but you hear it. You can turn it down, and we can stop it, and we can restart it. So let me stop that now. That was pretty quick, wasn't it? My first setup some 4 or 5 years ago took me 3 days. Those were the times when QtCreator and CMake were like fire and ice. They didn't like each other, and so they well, didn't want to work together. Then QtCreator and CMake went through some serious marriage counseling and got better. And my times got better as well. So over the years, my setup times went down to a day and half a day, but they never went to, say, 2 hours, 1 hour, or a couple of minutes. And then I installed a commercial boot2Qt version, and I was surprised to see that everything was set up. So the CMake toolchain files were there, they were working, the QtCreator was configured right out of the box. And I thought, hey, I want that too for the LGPL version of Qt. And that's when I started searching, and I actually found the magic script, the configure QtCreator.sh, and I also found out that it's under GPL version 3. So you can take it, change it, extend it, and make it work for yourself. And that's what I did, and that's what I showed to you.
So pretty impressive, isn't it? And I think it's really, you can really do it in 5 minutes. And as I mentioned, well, wasn't that always that easy, but by now I have used the script successfully on a couple of platforms obviously for the Torodex Word in IMX 8M. I've done it for the Seco A62 SBC platform, which is powered by a quad-core IMX 6. I've done it for Raspberry Pi 3, and it worked splendidly. Nevertheless, I do not expect it to work for on every SDK. There will be bugs. I'm pretty sure, some things that do not work, and so if you try it out, you might run into some problems. And so I think it's good to know about what the script does, how the CMake toolchain files look that it generates, and how the QtCreator configuration files look. So let's first dive into the CMake toolchain files, how they are generated, and what they actually do.
Let us have a look how the configure QtCreator shell script generates the CMake toolchain files. The first interesting line is here, where the script sources the environment setup file of the Yocto SDK. And this environment setup script sets a lot of environment variables that are needed for cross-building against the SDK. And these environment variables will also be used in the script further down. So here the script generates the first CMake toolchain file. It's a one-liner, and here it generates the actual CMake toolchain file for our Goldfinger setup, which is a bit more complicated. And you see it uses the environment variables it sourced earlier, so the CXX flags, for example, and will write it out as an assignment to the CMake CXX flags variable. My modified configure QtCreator script writes the two CMake toolchain files to this directory. So it's a directory somewhere in the native part of the SDK, and then it's found under user share CMake and in a special toolchain directory. So you see two CMake toolchain files, one for Goldfinger, which contains all the specific stuff for our Goldfinger kit, and the other one is the OE-Qt5 toolchain file, which is the one-liner you saw in the script. There is a third CMake toolchain file, one directory up, which is here, which is the default CMake toolchain file. This file is available in every SDK. The other two in the subdirectory are only available if you run my modified Qreator script, configure Qreator script. The interesting thing is that the boot to Qt or commercial boot to Qt version installs these two CMake toolchain files during its installation. So it doesn't use the configure QtCreator script for it, but it does it somewhere behind the back. This toolchain file, so the standard one, is a top-level toolchain file which calls the other two shown above here and coordinates the whole all the three toolchain files. And QtCreator actually passes the top-level toolchain file to its to the CMake call. So if you go to the kit Goldfinger and then look at the CMake configuration, you see at the bottom, so the three lines at the bottom, it sets the toolchain file, and it sets it to exactly the standard OE toolchain config CMake file. So we can cancel that. So let's look at the OE toolchain config file, which is in the upper half of QtCreator. The Goldfinger one is in the lower half. So you see that the standard one, or the top levels toolchain file, sets the CMake variables from the environment variables. And the environment variables come from the environment setup file of the SDK, which the script, which you must source before. So this toolchain file only assigns values to the CMake variables if you have sourced the environment setup file of the SDK before. If you don't do it, all these variables here, which depend on environment variables, directly or indirectly, all these variables will be empty. And that's where now this comes in. So at the end of the toolchain file, you find include statements for all the CMake files in the .d subdirectory. So this piece of code will find the two generated CMake files. And one of them is the Goldfinger CMake file, which you see here. And you see that it has replaced the environment variables, so something like NCXX files, by their concrete values. That's why the configure QtCreator script sources the environment setup script of the SDK so that it can replace the environment variables by their values. So it replaces the say this environment variable up here by its concrete value and assigns this concrete value to the CMake variables. Basically, the Goldfinger toolchain file overrides the settings of the top-level toolchain file. And that makes it actually easy to switch between kits. So you will switch between the kit for your PC to do some development on your PC, run things there, and then eventually you run your application on the embedded device. And if you source the environment variables from the Yocto SDK, this switching will be a bit tricky. And you would typically end up with two QtCreator instances, one started in the Yocto build environment, one started outside, and you will be in for a pretty mess. So there is a second CMake file which is source, and let's look quickly into that. This just sets this variable OE QMake path external host bins. And this fixes a long-standing bug in the CMake files of the Qt modules. So if you have ever seen this warning, or actually it's an error warning, skipping because this variable is not defined, then it's because this assignment is missing. So you could easily put that in the top-level toolchain file and nobody would have a problem.
So that these were the details for the CMake toolchain files, how it's generated, how it's called from QtCreator, so that you have an understanding how that works. And now I'll explain the same for the QtCreator configuration files. So while you see them in QtCreator, obviously they are displayed there. But where are they located in your file system? How does QtCreator pull them in, and what's in them, and what is actually the tool you use to create or modify QtCreator configuration files? So let's see how all of that works together.
Our configure script generates a couple of QtCreator configuration files in a directory below the QtCreator installation. So you see XML files for the CMake binaries, for the debuggers, for the devices, for the profiles, or that's actually the kits, for the Qt version, and for the compilers. When we start QtCreator the next time, it merges these configuration files with the user-specific configuration files. The user-specific configuration files are stored in the home directory and then in the .config Qt project QtCreator directory. And the contents of these XML configuration files is shown in the Tools Options Kits dialog in QtCreator. The QtCreator configuration files are created or generated by a utility called SDK tool. Towards the end of the configure QtCreator script, you see a call to SDK tool for each section in your kit. So you see a call for the GCC compiler, for the C compiler. You see a call to the C++ compiler. You see a call that generates a debugger, the Qt version, the CMake binaries, the device actually, and finally the kit. SDK tool is located in a directory below the QtCreator installation. So it's actually in the libexecutecreator directory. You will not find a single bit of information about SDK tool in the Qt documentation. Your only chance is to use the available help for SDK tool. That lists a couple of operations. So for each section in your kit, there is an operation to add a tool chain or a debugger and to remove it. And then there are some other helper functions like getting a setting or finding settings, finding setting keys. So if you need more help for a specific operation, you type SDK tool -- help with the operation. Say we want to know more about adding a toolchain or a compiler, then we enter this command and it lists all the options for this command. So there's always an ID, and then the language, that would be the C or C++, the path of the compiler, and so on. When you look at the call for generating the C++ configuration, you're probably wondering how I came up with the option values. Some of the option values, like ID and name, stem from the original configure script. Other option values, like path, are calculated on the fly. For the magic language number, I had to do some reverse engineering in existing configuration files. So I figured out that C++ compilers have the magic number 2 and C compilers have the magic number 1. The ABI is defined at the beginning of the script and it's actually hardwired. For the IMX8, it's ARM Linux Pokey Elf 64 bits because the IMX8M is or has a 64-bit architecture. For other SOCs like the IMX6 or IMX7 or the Raspberry Pi 3, 2, and 1, you would use 32-bit here. This SDK tool call generates this section in the toolchain's configuration file. You see the very long path to the C++ cross-compiler. You see the ABI flavor here. You see the display name. And you see the specially formatted toolchain ID here. And finally, you also see the magic number 2 used for the C++ compiler. The QtCreator reads this XML file and displays its content in a more humanly readable format in tools, options, kits, compilers, and then we click on Goldfinger, and here we see the option values which we just saw in the XML configuration file. The call for generating the kit configuration pulls together all the pieces we have defined before, like the device, the Qt version here, the debugger, the C compiler, the C++ compiler, and most importantly, the CMake configuration. This line here actually makes sure that QtCreator always calls CMake with the correct toolchain file. And this toolchain file is actually the file that is created by our configure QtCreator script.
So that brings me to the end of my talk. You can find the contents of the talk as a post on my website, actually. So I've written it down. If you find any problems with the script, let me know. You can email me here at my business address, and obviously the script, the configure QtCreator script, is available on my GitHub account. It's under GPL version 3, so the original is under GPL version 3, so mine is as well, and it contains a couple of modifications. So, yep, that's it from my side, and I'm now open to questions. And yeah, thank you very much for attending my talk.
Thanks, Burkhard, for showing us this quick way of integrating complex SDK setups in QtCreator and also in so much detail. I will certainly check it out and check out the script for myself in the future, because I know the pains of setting up an SDK for
a fellow sufferer then.
yeah, I know the pain as well. Yeah, we have some questions. The first, I think you answered it partly already in your talk. Which kind of Yocto SDKs do you think does your setup operate on? Like, what do you need? What do you think is needed in those Yocto SDKs, or are Yocto SDKs in general built in a way that chances are pretty good that you can kind of use this as an input for the scripts you've shown?
I think what I mean by Yocto SDK is always it's a Yocto SDK which includes Qt, obviously, and that is probably the thing which pulls in all the CMake stuff, which is under I think under Qt directory as well. So that is probably the requirement, but it has worked for something like some antique version of Yocto, like Rocco or Thud, and it has also worked. So in the talk, it was Dunfell, so the very latest one. So it should be fairly flexible there.
Yeah, that sounds actually quite nice. So also good for me in the future.
And maybe what is important if you talk about versions, it's not so much Yocto, but it's QtCreator should be and CMake. You normally, so my experience is you just best use the very latest versions of CMake and QtCreator. There is no reason why you should use older versions. Because the CMake integration got a lot better over time. QtCreator version, so the oldest one you can properly use is 4.11. CMake is, I think, 3.14. Before that, they do not really work well together, so you have to jump through a lot of hoops.
Mm-hmm. Yeah, this is also where our next question connects, I think. CMake became kind of the most prevalent build system in Qt nowadays. Do you think the toolchain files will become kind of a central mediator or moderator between those SDKs being generated and the IDEs that work on them, independently of whether being QtCreator or being Visual Studio Code or something like that? Do you think those toolchain files will become kind of the glue between SDKs and IDEs?
Yes, absolutely. You can't do that without the toolchain file. And using CMake and the proper toolchain file makes it easy to use whatever IDE you prefer. So for me, it's QtCreator. I will certainly look into Sea Lion soon. Refactoring stuff sounds very tempting, or you can use Visual Code. So it's CMake which makes that possible to use whatever.
Have you heard anything? Do you think this intermediate step of this QtCreator XML, which kind of gets generated out of the toolchain files, will go away at some point? Well, you maybe can only speculate, right? Just having the toolchain file as an input.
I think QtCreator will always need some configuration file, and probably other IDEs have their own configuration files. You might be able to read that out of the CMake files. I'm not sure whether you can do everything. It would be worth looking into that. And then QtCreator and CMake have an API where QtCreator can request data. Might be possible, but I haven't really thought about it yet. Mm-hmm. Good question.
About the SDK tool you showed as a kind of this QtCreator SDK tool you showed in the end. Is the code for this visible somewhere? Because you said you need to reverse engineer something. Can it be inspected and like extended or at least understood in a way?
Yes, it can, and it is. You find it in the same directory as the or under the same directory as the QtCreator sources, so it's somewhere there. And I actually looked into it and to figure out what's going on, because there is no documentation. And if you want, for example, you saw that the kits I generate are auto-detected, so they are always disabled. You can't change them. And you could change the source code of the SDK to say it's set auto-detected to false, and then they would come up under manual. But I didn't want to do that, so it's what you get. And if I might do it later, so and provide the changes. Let's see.
Okay, thanks for the talk, and maybe a personal comment also. Thanks for the info on the host bins error, which has been bugging me personally in my daily work.
Yeah.
Which I never could explain for myself. So again, thank you for the talk.
I don't know why that thing is in there. It has been there for ages. You can just move it into your top level toolchain file, and everything is fine, and nobody would have a problem. But yeah, one of the mysteries. And you're welcome. It was fun giving that